Okay, everybody, welcome to our Instructor Training Center Routing Switching Essentials class. We're going to jump forward and look at Chapter 6, Vlans, as that's what's on the schedule for this week. The big thing about this chapter and about Vlans in particular is virtual LANs depend upon switches, and we'll talk about inter-VLAN routing. We do talk about the way you can route between them, but what we're going to look at is, imagine you've got a switch, and that switch is a 24-port switch. And you need to put 12 PCs on one network and another 12 PCs in another network. In other words, you've got, well, here's an even better example for those of you, since most of you are at school. So imagine in your classroom, you've got an instructor station and you got student stations. You don't want the instructor station to be on the same network as the student stations for various reasons. One is they're doing all kinds of nefarious things you don't want them to do. Plus, you just don't want them to have access to the instructor machine. There's two ways you can go about separating those particular networks. One in the old days would be to literally take a router like this, buy two switches, and make one switch that you plug the instructor PC into and another switch you plug the student PCs into. The problem with that is, imagine a school we only have three instructor PCs and say 20 student PCs. Well, if you buy a 48-port switch for each one of those, you're wasting tons of ports. So Vlans allow us to take a physical switch and cut it into different virtual LANs. It's very important that when you think about, one of the things I always teach my students is Vlan equals network. Okay, network, or most time it'll be a subnetwork, but Vlan equals network. So if you've got a Vlan 10 and a Vlan 20, then you've got to have two separate networks. In other words, Vlan 10 is going to be 192.168.10.0/24, and Vlan 20 would be 192.168.20.0/24. So two separate networks. We'll learn too about tagging and how switches tag the frame with a Vlan tag identifier, an 802 or .1Q tag. In our networks, there is another called ISL, but we don't really deal with that anymore. But it tags it so that it's only associated with a certain VLAN, so that only hosts on that VLAN can talk to one another directly. So, VLAN definitions. When we look at Vlan Groups, or VLAN itself, just think of VLAN equals network. It can span multiple floors. It can span multiple switches. It could and used to span multiple buildings. You could have, a VLAN. In the old days, we had networks that were flat layer 2 networks. In other words, we had it here on our campus where we had VLANs that spanned multiple buildings on campus. We don't do that anymore. We have, in most modern networks today, route between buildings and then keep the VLANs and the STP, the spanning tree traffic, that I've talked about, and we'll talk about more as we move forward. But the spanning tree traffic, we keep within the building, and that's something we'll talk about when we get into connecting and scaling networks. But this is an example of, you've got IT workers on 3 different floors, HR workers and sales workers on 3 different floors. And instead of having to put 3 different switches on each floor, you can use VLANs to assign on a per port basis what VLAN a particular device is in. Benefits: security. The instructor machine that we were talking about, the students can't get to it without going through a router, which means you can set up access control lists and not allow them to go there. The students, different VLANs equaling different subnets or different networks means that broadcast traffic is contained within that network. So only host in Vlan 10, that faculty network, will see broadcast on Vlan 10. No one else will see it. Reduce costs. You don't have to buy switch per network. Better performance. Okay, maybe. All right. So it does reduce the size of the broadcast domains. Now, it gives you more broadcast domains, but it reduces the size of broadcast domains. So I will say, yeah, okay, I agree. Better performance. 6.5 doesn't. I'm not totally convinced on that one. Depends on how you design your network. It does reduce the size of the broadcast domains, though. It creates more broadcast domains. Okay, because if we had no VLANs right here, we would have one broadcast domain. which would be a bigger broadcast domain. There'll be 6 PCs in that, and also these devices in that broadcast domain. With VLANs, we now have 3 broadcast domains, but they're smaller broadcast domains. They're 2 PCs apiece, which is kind of nice. It is efficient, more efficiency, because you can provision and manage your VLANs easier than having multiple switches spread across all different types of things. And also even simple project and application management, because you can group PCs and devices together by their function, not necessarily by where they're located within a building. Now, different types of VLANs. We have data VLANs. That's a VLAN we're going to tag with a specific tag number. We put a port into that VLAN, and that is a VLAN that data travels on. We can use it for all different types of things. It could be management, it could be voice, it could be just pure data, whatever. There's also what's called the default VLAN. That is VLAN 1. And VLAN 1 is a very dangerous little rascal. All ports by default are in VLAN 1. So if you use VLAN 1 for management, or if you use VLAN 1 for anything, the VLAN 1, if you plug into any port, as long as that port's not shut down, which on switches by default they're not, they would have access to all the broadcast traffic going across on VLAN 1 or the default VLAN. So what we traditionally and typically do is since VLAN 1 cannot be renamed, cannot be deleted, we create what's called a black hole VLAN. We create a VLAN 555, 666 if you want to be humorous about it, and you take all the ports and stick those ports into the black hole VLAN. So we take them out of the default VLAN and we put them into a black hole VLAN, so that you don't have to worry about the traffic, anybody actually getting access to the ports by just plugging in, because they'll be in a black hole VLAN that's not used for anything. It's kind of a staging VLAN. Native VLAN we'll talk a little bit about. It's a weird little beast, and that is a VLAN that is not tagged on a trunk link. And we'll talk more about that as we move forward. It's easier for me to explain that one until you're showing you the diagram. It's a very much legacy item, but it's something we have to set on our trunk ports to keep from having the trunk ports bark at us and give us error messages. And then we have management VLAN, and we should never use VLAN 1 for management VLAN. It is the VLAN by default. It is by default that, but don't use it. We really should assign a switch virtual interface on a different VLAN and then use that as your management. We've used 99 in our courses before. We've used other things. Voice VLANs. This is something that's not that difficult, but it is a little weird because people don't really think about it. And that is, when you stick an IP phone onto a network, the IP phone has its own voice VLAN, depending on how you set it up. And that voice VLAN, because the IP phones that we have, almost all of them in the real world, have a trunk link between the switch and the phone actually has a little built-in switch on it. The student PC is then connected to the phone, and it gets encapsulated, or it gets tagged, not encapsulated, it gets tagged with the correct VLAN information. So in this case, what would happen is all voice over IP traffic would be tagged as VLAN 150 and be given priority based upon the quality of service you've set on switch 3 and switch 1 in your network. And all data from the PC would be tagged for VLAN 20, and that would have standard priority, so it would not be able to preempt traffic from the IP phone. Now, VLAN trunks. Here's one thing to think about. All ports typically are, well, all ports are in one of two modes. So when you look at a switch port, it's going to be an access port or it's going to be a trunk port. Now, access ports can belong to only one VLAN. All right, period. That's it. They are designed and they cannot carry tagged traffic. So if a frame goes out a port and that port is an access port, so this would be an access port right here. If you tried to send a tagged frame across this link, first off, the switch would strip it because it's an access port. Second, if that tagged frame got to PC1 and PC1 saw it, it would see it as an Ethernet frame that's too big and it would throw it away. Now, those of you out there who use Hyper-V and VMware and ESXi and all these different data center technologies, you know for a fact that you can take a server, you can turn on tagging, you can actually make a trunk port that goes to a host. But typically, unless you're in a data center environment or you're going to a server, links to host are going to be access ports. Now, trunk ports are different. They carry tag traffic. All right? And typically, they will have what's called a native VLAN set up, and that native VLAN will be untagged. And we'll talk more about that as we get there, but trunk ports do not pull the tag out when the frame goes across that port. That's what these would be. Because you've got, on both sides, you've got VLAN 10. If PC1 sends something to PC4, it would come in as just a normal frame. As it comes in on S2, it would be tagged as part of VLAN 10. It would then be sent across this trunk port, still tagged, across this trunk port, still tagged. And then as it goes out F011, it would have the tag removed before it went out to PC4. In addition, one of the neat things about this is, be aware that as far as traveling from S2 to S1 and S3, it would still have to do a content addressable memory table lookup. It would do all the typical things that we do to get across a switch. But that tag would be maintained across these trunk links. But the second you leave an access port, that's the key. The second you leave an access port or go out an access port, that tag is removed. Cannot have a tag on it. Now, what we use, and there are multiple different types of tagging, really two main ones, but we use what is called 8021Q, or many times we call it .1Q. .1Q. There is an older tagging method, ISL. Hey, Sandello, how are you?
I'm doing all right. I'm sorry for being late. I was just getting through the traffic.
That's okay. That's no problem. This is an older technology, interswitch link. So that's an old technology that's out there, but not used much anymore. Almost everything's .1Q.
Mm-hmm.
By default, we're going to be using .1Q tagging, and we are going to set up ports, trunk ports to be .1Q, or also our sub-interfaces on routers to be .1Qs. But here's a network without VLAN. So you send out a broadcast, look what happens to it. It goes out every port except the one it came in on. And as soon as you VLAN, now notice here too, watch this. See, these are all 1740/24s. But the second you put in VLANs, now you got multiple different networks, because VLANs equal networks. Now that broadcast will only go to the VLANs associated with the port that PC1 is in. So again, VLANs create more broadcast domains, but they are smaller broadcast domains, or should be smaller broadcast domains. Again, especially in this day and age when we've gotten away from flat layer 2 networks across campuses and gone to routing between buildings. So, now, here's our .1Q tags. Here's what happens. You take a typical frame, and between the source MAC and the type length field, you throw in the .1Q tag. And you go in and you put in a type. Okay, for Ethernet, you set it to 0x8100. That's your type. You've got a user, a 3-bit that can be used for service implementation level. And then you go in and you got a canonical format identifier, CFI. That's if you're using token ring, which we don't. And then you got a VLAN identifier, which in this case allows you to go up to 4096 VLANs. Okay. Now, once you put this tag in, the switch does recalculate the frame check sequence. It has to, otherwise the frame would not be valid, because the frame would have been changed from when it was sent by the original PC. And everybody dropped off. I must be bored today, Sandela. All right, now this is one of the hardest topics to explain to your students. It's also one of the dumbest things about trunk links out there, quite honestly. But because of legacy requirements on trunk links, Ethernet cannot assume that a link does not have a hub on it, even though hubs are of the devil. It cannot assume that it doesn't have a hub on it, and it cannot assume that that hub on the trunk link doesn't have a device on it. Okay, now, modern networks are not going to have a hub on the trunk link, unless for some crazy reason you're throwing a tap on there, and then you're probably still going to do it somewhere differently, or you're going to do it with a span, you know, using span ports or something like that. But just humor me on this one. What happens on a trunk is all traffic on a trunk link is supposed to be tagged, period. So if you've got a trunk, you tag it on one side, it should be received tagged on the other, and vice versa. If you set, which you must set, when you set the native VLAN, that will be the one VLAN on the trunk port that is not tagged. By default, that is VLAN 1. So when you set a trunk up, by default, the native VLAN is VLAN 1. And we just told you that VLAN 1 and altogether is evil because it is a security hole, because all ports are in VLAN 1, and we just try to get everything off of VLAN 1 as much as we can. So it's actually a pretty good best practice to make your native VLAN on both sides a non-existent VLAN that you set as the native VLAN on both sides. And if you don't set it, the big problem is one side barks at the other one and says you got a native VLAN mismatch, and it drives you crazy because you keep getting output on your console, or if you're doing syslogging, you'll end up with 5 billion syslog messages. From an actual working standpoint, you really shouldn't have anything on the native VLAN anyway. So even if you have a native VLAN mismatch, the link will still work for all the other traffic. You just get all types of error messages. Now, Sandello, tell me if I'm wrong. You know any other reason why you use a native VLAN?
Outside of what you discussed, not really.
Yeah, it's such a legacy item that, you know, it's just really, really weird. Yeah. But it's something we had to set. So now this is kind of cool though. I like this diagram. I like the fact they've added this into the curriculum, and that is the concept of the phone. Cisco IP phone has its own built-in switch, and it actually uses, this is where people get in trouble many times. Cisco phones and Cisco switches use CDP to set up the trunking between the Cisco phone and switch. So if you turn off CDP or Cisco Discovery Protocol, you can actually kill the connection. And there are different ways around it, I know, but that's one of the things that can be an issue. But the switch on the phone and the switch in your closet actually create a trunk link, and then they tag voice traffic with one VLAN. Now they're saying 150 here, but you can change it. I mean, that's not set in stone. That's just what they've done in this case. And then you can set priorities for voice frames, and then set the other traffic from the PC to the data. So here you see an example of a switch port that you've got trunking native VLAN 1, and you got access mode VLAN 20 and voice VLAN 150. So we're not going to teach you how to do in this class voice over IP configuration for switch ports, but just be aware it uses the same .1Q trunking that we use when we trunk between switches. Now, Vlan Ranges on a Catalyst switch, 2960, 3560s, has the ability to do 4,096 VLANs. We do have some set aside by default, obviously VLAN 1, 1002 through 1005, which are tug and ring, fiber distributed interfaces, FIDI. And then there is an extended range, excuse me, can't talk today. Extended range, which is anything between 1000 and 4096. And there are even, you can actually get VLANs beyond that. So it is possible, depending upon what type of switch that you have. The Catalysts only have a 12-bit field in the 802.1Q. But there are ways around that with extended VLANs and different types of things down the road, beyond what we do here. Now, the cool thing about VLANs is they really are pretty simple. You create the VLAN, and then you put ports in the VLAN. So one of the things I will show you that you can get in trouble with, and I've seen this many, many times, and let me see if Packet Tracer actually mimics this behavior. I don't think it does. But it used to be in the old days, when you put VLANs on a switch, you would go into a different mode. You wouldn't even go in, you were not in global configuration mode. You were in a different mode altogether. But now we go into global configuration mode to do VLANs. And I'll show you Let's see if this actually works the way it's supposed to, or if it's because it's a simulation, it doesn't. Let me try to. Oh, I bet I can't make it any bigger. No, I can't. Okay. So let's do this. Let's do a show VLAN. You'll see that right now I've got on this particular switch my default VLAN of 1, and I got my extended VLANs of 1002 to 1005. I'm gonna do a config T, and I'm gonna do host name, host. Oops, can't type. Host SW1, and I'm going to do VLAN 10 name test, and then I'm going to do show VLAN, and you'll notice. All right, this is. Let me go get a. I might have to go get a NetLabs preservation. Let me go grab one of those real quick because I want to show you. This is something that gets people in trouble in some cases, especially if all they work on is packet tracer, which you shouldn't be doing because that is actually not supported under the Cisco Academy. You need to be using real gear because I've never again seen anybody that was hired for 2 to 5 years of experience with packet tracer. You should always be working on real gear whenever possible. I'm gonna let that boot up. But on a real piece of equipment, what actually can happen is until you type exit, the VLAN doesn't go in the VLAN database, because if you do a do-dir, this VLAN.dat is where the VLANs are stored, and if you're inside of that configuration mode until you exit, the VLAN is actually not placed into the VLAN.dat. So I'll show you that in just a second. But for us, we're going to create the VLANs. Okay, no problem there. And then assign the ports to the VLAN. So you can go in and set a port into the VLAN. You know, you can obviously use an interface range command if you want to do multiple ports at one time. This is an example of a single switchport mode access. So it's a single port placed in the VLAN 20. If you did ranges, you could go in and do multiple ranges. Okay, now this is an example of configuring data and voice. VLAN 20 named student, VLAN 150 named voice. Then your switchport mode access, switchport access VLAN 20. Then you do MLS 2S trust cost, which is setting your actual quality of service standards. And switchport voice VLAN 150, and that will tell the switch to make 150 the voice VLAN. The important thing is to make sure you do create the VLAN and then assign ports to it. Now, if you don't want a port to be part of a VLAN, you can do no switchport access VLAN and the number. And then be aware, it doesn't mean it will have no VLAN. If you do that, it will then drop back into VLAN 1, okay, by default. So be aware of that. And don't forget my suggestion that you create a black hole VLAN that you place all your ports in. All right, let me see if I can get into this real quick. See if we got it up and booted. And show you actual behavior. And I'm going to change my presets. Give me just one second. Are there any questions as I'm doing this?
No.
All right. Get the font a little bit bigger for us. So this is a real switch booting up, and this is the lab I'm actually working with. I'm working with this lab right here, which is 2 switches, 3 PCs. Okay, so I'm in switch 1 right now, and it's actually booting up. So just let it finish booting, and then we'll come back to it, and I'll show you what I was talking about. Show interface FA018 will show you what VLAN is part of. Also, you can do a show VLAN. That's what I do, show VLAN brief or show VLAN. We'll show you all your VLAN information. If you need to delete a VLAN, just go in global config and do no VLAN. Be careful that you don't orphan ports. If you delete the VLAN that a port is assigned to, that port will go amber and it will be unable to communicate with anything. So be careful with that when you actually go in and do deletion of VLANs. Make sure you moved all ports out of the VLAN then delete the VLAN. Show VLAN ID and the VLAN ID number. So show VLAN 10, show VLAN brief. Those are all different commands that will show you information. Show VLAN summary about just your VLANs. And then you can also look at under the interface commands, there are different items you can do. Show VLAN name student will show you all the ports in that VLAN. Happen to know them. Show interfaces VLAN 20 will show you the SDI, the switch virtual interface. You'll even notice here, hardware is Ether SDI, which means it's a switch virtual interface. So it's not a real physical interface on the switch, it's an SDI. And that's configuring VLANs. We'll come back to that in 1 second. Let me, wrong one. Here we go. All right, so we're in the switch. Now let's do this. Show VLAN. So we see that there's only the default VLANs here. We don't have anything else. Okay. All right. So now I'm going to do a config key hostname SW1, and I'm going to do a VLAN 10. Oh, not 19. No, VLAN 19. Got rid of that. VLAN 10. I can type name, management, or whatever. All right, enter. Now I'm going to do show VLAN. Look, this is how the real iOS works. There's no VLAN inside the VLAN.dat yet because you are still in configuration mode. I've seen many people, especially those of us who like to use the do command and jump around. It's not there yet. And this is a legacy left over from when it used to not even be inside of global config mode. It was in its own little mode to do VLANs. If I type exit and drop out of config VLAN mode and do a do show VLAN, watch what happens. Now VLAN 10 is there. So you'd be amazed the number of times I've seen people go in here and say VLAN 20 on this switch, and I do name, oh God, I can't type today, name, HR, and then they'll go over to switch 2, and they've got a trunk port, and they're doing BTP or whatever, and it won't communicate. And it's because on a real piece of gear, not a packet tracer, on a real piece of gear, it does not write the VLAN into the VLAN.dat until you exit config VLAN mode. All right? Be aware of that. That's something I see a lot out in labs and in watching people work on VLANs in your classroom. You will see this. And they'll be like, well, I created it. And you look down and they're still in that config-VLAN mode, and it hasn't been written to the VLAN.dat yet. All right, so now here's the thing. If I do a show VLAN or do show VLAN, you'll notice I have no ports in that VLAN. So nothing's really going to work because I don't have a port in there. So let me go over and pull over my, actually look at my reservation. And let me go back into my, no, not that one. Gotta go back into my, there it is. Okay, so port 06 is connected to PCA, so I'm going to make that in VLAN 10. So what I got to do now is int FA06, switch port mode access, because this is an access port, switch port access VLAN 10. Now if I do a do show VLAN, you'll notice that actually does get moved automatically over there. So you don't have to worry about, it's only the creation of the VLAN that doesn't get written into the VLAN.dat until you exit config-VLAN mode. Okay? Now, I'm going to go ahead and set up these trunks because it's just to make it simple. So I'm going to take 01 and make it a trunk, and it's extremely simple. Okay, int FA0/1. It's literally the only thing I had to put in is switch port mode trunk. Now, there are some optional commands. You can do switch port trunk. Oops, you can do switch port. Golly, I can't type. Switch port trunk native. Obviously, you can change the native VLAN. I'm gonna change it to 99 on here, and I forgot to put VLAN. VLAN 99, and we'll start getting error messages here in a minute. Let me go ahead and do this. So I'll end up with junk all over my screen. Logging synchronous. Okay. Drop back out. And I can also do int FA01, and I'm going to do switch port trunk allowed, and then you can allow VLANs. By default, all VLANs are allowed, okay? Or you can only allow some VLANs. So I'm not going to change that right now, but that's an optional command. So I'm going to jump over to switch 2 and hopefully pull it up. Yeah, it just didn't. I got to do keep, and I got to open the JNLP because Java is no longer supported in browsers, not without going to external. I'm just going to real quick make this SW2, Vlan 10. Oops. See that native Vlan mismatch? See how it's already started? So I'm going to go actually int FA01 switch port mode trunk. And by the way, on these switches, it only supports .1Q, so you don't have to set the encapsulation mode. I'm going to switch port trunk native Vlan. Notice I'm using the tab 99, so I just fixed that problem. Line con 0 login. This is just to keep it from doing messing up my typing. Then I'm going to do Vlan 10 name management. Okay. And then we'll exit. And then I'm going to do int FA011. And I'm going to do switch port access, switch port mode access. First, you're going to make an access port. And then you do switch port access Vlan 10. Now, if I put IP addresses on PC A and B, they'll be able to ping each other now. With no issues, it wouldn't be no big problem there. I'm going to go back over here and do this and show you a couple things. Now that I've configured trunks, I can actually do Control-Z. I could have done it there, but I'm going to show int trunk. And you now see the FA01 is trunking. It's got a native VLAN of 99, .1Q encapsulation. All VLANs are allowed on the trunk. Okay. And it shows you what VLANs are actually active on this. Show VLAN. And I'm actually going to go in here real quick and just put IP addresses on this so I can show you pinging between these to prove it actually works. But we've set up VLANs. We've configured the VLAN. We put ports into the VLAN. And then we've actually set up trunks between, or a trunk between switch 1 and switch 2 to allow them to be able to carry multiple VLAN traffic or tag traffic. So let me go in here and go ahead and open this up. And I'm just going to use 192.168.10.0 as my network. You'll notice there's no routers in this particular network, so we're not going to be able to route between VLANs anyway, because you must have a router to get between different VLANs, because VLANs equal networks. Let me go back over to PCB. So in this particular setup, no matter what you did, you would never be able to access PCC from A or B because you don't have a router with what we have here. Now, you're going to learn how you could actually, even on a 2960, enable some routing capabilities with switch virtual interfaces. But we don't do that till later in the chapters. And the way it's set up right here, you would not be able to get between the two VLANs. So let's put this in here, and this will be 192.168.10.11. Tab it over. Okay, okay. And CMD. Oops. Nope, that didn't do it. CMD. And we can ping 192.168.10.10. Oop. And it helps to put the right IP address in. 10.10. General failure. All right, let me see what I did wrong here. We got no. Go back on switch 2. Check what I did wrong. Oh, connected. Okay, that's working. Let's make sure I got it in the right. It's in Vlan 10, which is management. That is correct. Doing a show at trunk. Trunking is on. Oh, that's good. All right, let me do something here. Let me, on occasion. Oh, that's one. Look at me.
Yeah.
I made the mistake. I put the wrong IP address in. That was a test. I was testing the class just to see if you were paying attention. Now let's try it. There we go. So now we're pinging from PCB up to switch 2. By the way, the information is untagged as it comes into switch 2. Then it's tagged as part of Vlan 10, crosses the trunk tagged, and then once S1 goes to send it back out this 06, it untags the information and sends it out to PCA. So the access ports 06 and 011 only have untagged traffic on them, and the trunk ports 01 have tagged traffic on them. So that was a very quick example of exactly how you can set up this network with multiple VLANs and a trunk between it. Are there any questions on that? None? Okay. Yeah, it's pretty simple stuff, pretty cool stuff.
Yeah, it is. Mm-hmm.
There's a lot of this, the routing switching class, I really like the way things work in the labs because they're pretty neat. So configuring the trunk, switch port mode trunk, you can set your native VLAN, and then you can set your allowed VLAN list. Now, one of the common problems you will find on trunks, and then we can talk about troubleshooting trunk links, is that one side is allowing one set of VLANs, and the other side is allowing a different set, or you set allowed VLANs and you go add a new VLAN and forget to add it into what's allowed. So that's a very common mistake also. So here we're looking, in this particular example, you've got 10 through 99, and you're going to allow just those particular VLANs, so 10, 20, 30, and 99. DTP, they talk about dynamic trunking protocol. That is actually beyond this course, but it will be in the next courses in scaling. We'll talk a lot about dynamic trunking protocol and how you can actually use DTP to allow two switches to negotiate a trunk. I'm highly against DTP for security reasons, but it's out there, and we do talk about it when we get into the scaling class. Now, if you want to reset a trunk to its default state, you do no switch port trunk allowed VLAN and no switch port trunk native VLAN, which means by default, the trunk allows all VLANs and it's part of native VLAN 1. So you'll see that. So the access mode VLAN is 1, which is the native VLAN, and then you've got allowing all VLANs to go across. If you do not want a port to be a trunk anymore, you simply put in switch port mode access. And then you will be able to see that port is now an access port. So it only cannot carry tag traffic. Show int trunk or show interface F01 switch port will show you what's a trunk. My favorite is simply show interface trunk. And that gives you quick, dirty information on the trunk itself. Gives you everything you need in my personal opinion. Now, what are some of the issues with VLANs and trunking? Remember again, VLAN equals network. One of the most common issues is, what did I just do? I just showed you the most common issue. I put the wrong IP address on PCB. I had 1.10 instead of 10, or 1.11 instead of 10.11. So I actually did the exact same mistake they're talking about here. I had it on the wrong IP address. So that's a very common thing. And that wasn't even on purpose. Missing VLANs, one VLAN, you have a VLAN on one side but not on the other. Or, for instance, given our example, one side you put one PC in VLAN 10, and the other side you put it in VLAN 20. There's no router between them. They will not be able to talk to each other. So missing VLANs, you can do a show VLAN to see that. Trunks, honestly, one side trunking, the other side not trunking. one side allowing one set of VLANs, the other side allowing a different set, one side set to a different native VLAN than the other, and you'll see that immediately because CDP will tell you and start barking at you. But show int trunk, FA01 trunk will show you this, or just show int trunk will show you all your trunks. Down the road, we're going to learn about ether channel and about combining multiple links into a port channel so that you can actually have trunks that are more than just one particular physical link together. Here you see again CDP telling you got a native VLAN mismatch. Other than that, that's pretty much it. You got incorrect port mode. You forget you set one side of trunking and when it should be an access port, or set one side to an access port and it should be a trunk. Incorrect VLANs, so you don't have the right VLANs, or you don't have all the VLANs allowed or all the VLANs created. Or also, it's very common to see someone create the VLAN and then forget to put the ports into the VLANs. And that's honestly all there is to creating VLANs and trunks. The next item is, how do we get between VLANs? How do we go from VLAN 10 to VLAN 20 or VLAN 10 to 30? That's inter-VLAN routing. And to do that, you've got to have a router because, again, VLAN equals networks. I can't say that enough. In legacy inter-VLAN routing, you would have 2 ports on the router. One, these, by the way, the ports on the router are not associated with any VLAN in terms of actually being tagged. This port, FA01, would be put in VLAN 10. FA011 would be put in VLAN 10. And then the PC would send information, and when it would come in, it would get tagged. And as it was leaving the switch, it would be untagged. So these links to the router are not tagged at all. These are access ports. And then there'd be an IP address in VLAN 10 on gig 00, and an IP address on VLAN 30 on gig 01. I got to do some updates, y'all. Push button. And then the routing would take place. It'd come up, go up this interface, and then go across, and then back out. That is legacy VLAN, inter-VLAN routing. Now, the problem is, if you have more than 2 or 3 VLANs, you've got to have all those ports on your router. So that is an issue. There is a good thing about it, and that is you're dedicating the bandwidth of this link to that one VLAN. Whereas if you do what's called router on a stick, okay, now this is just another example of legacy inter-VLAN routing. But if you do routing on a stick, what you end up doing is you actually create a trunk link between the switch and the router. And if you're going to route between different VLANs, you have sub-interfaces on the router that are associated with certain VLANs. And so if you're going from VLAN 10 to VLAN 20, it would come in, go up, tag this VLAN 10. R1 would do its route, look up, and then send it back out to VLAN 20. So it would use the one link as a trunk. And the negative here is you're sharing the bandwidth. The positive is you don't have to have multiple ports on your router to handle the inter-VLAN routing. Router on a stick is one of the more common ways in smaller networks. Smaller networks of data, we're going to use switch virtual interfaces. And I don't even know if they're showing that. Let me see if they get down. I got to go away to show you switch virtual interfaces. They're not even really showing it. But a switch virtual interface is our more common way of doing things now. And what we do there is we have a switch that can route. We have a multi-layer switch. So when we look at doing SVIs, it's really a little bit beyond what we talk about here, but we talk about doing layer 3 SVIs. So we take just one switch and make multiple SVIs. So it'd be an SVI for VLAN 10, switch virtual interface. So it'd be interface VLAN 10 on the switch, interface VLAN 20 on the switch, and then enable routing on the switch itself. So router on a stick, it's easy. There's really not a whole lot to it. Legacy is even easier because all you have to do is go in, create your network like normal. Okay, so you set up all your switch, set up your VLANs, set your ports into the correct VLANs, and then on the router you just create the ports, put IP addresses on them, and you bring the ports up. Now, especially in this case, because the 2 networks you're routing between, they're both directly connected. So you don't need a routing protocol, you don't need static routes, nothing. You have 2 directly connected interfaces. So extremely easy to do. You can see here, once you bring up put the IP address on the router, 2 IP addresses, and then bring them up, and it will start routing between the 2. Okay, because you've got your connected routes, C and L, so connected and local. Router on a stick is a little bit more work because you do go in and set up first the Vlans on the switch, but then you're going to go on to the switch, to the router itself, and they really should get rid of one of these links here, because you're going to go into the router and you're going to create one physical interface. You're going to go into that interface and create what are called sub-interfaces. These are virtual sub-interfaces. You'll do encapsulation .1Q10, and this is associating that sub-interface with VLAN 10. Now these numbers do not have to match, but it's a really good idea. If it's VLAN 10, make it sub-interface 10, and then you do have to have the 10 here for the VLAN ID. Put the IP address in, and you go in and do the same for your other VLAN, and then do a no-shut on the actual physical interface. And at that point, it's going to route between the two different VLANs using those sub-interfaces. Show VLAN on the router, you'll see your two different sub-interfaces, VLAN 10, VLAN 20, using .1Q encapsulation. To show you IP route, you will see the same thing connected and local, but they're all on their own sub-interfaces now, not on a single one physical interface per. And so it's really, you do that, and then you do your routing, and it works. It's super, super simple. And that's really this entire chapter in a nutshell. Okay, it's not anything majorly difficult with VLANs or inter-VLAN routing. So are there any questions on any of these items?
And it has to be no IP address actually on the interface for that, the one that you set up for the interface. Good
question, Sandela. Yes, that is correct. There can be nothing placed on the actual physical interface that is used for your sub-interfaces. That's correct. So when you hang, if you're using gig 00 as your sub-interface, you don't want anything configured on the physical interface. Another interesting point is this. You can actually go in and shut down individual sub-interfaces, but if you shut down the physical, the main interface, so the gig 00, all sub-interfaces go down. Okay. But once you bring up the physical interface, you can go underneath and shut down individual sub-interfaces with the shutdown command. And that's a common mistake. A common mistake is forgetting to do the no shut command on the physical interface.
Right.
Okay. Any other questions? Our next chapter is access control list, and this is one where ACLs are used for everything but the kitchen sink in Cisco. So it's a very important chapter because we look at how we can do everything from controlling traffic to route distribution, route list. We've got controlling access to the V2Y lines, everything using the ACL information. So I'm going to stop recording real quick.